In this example, we're told that a rectangle has an area in square inches, and three variables are defined: W, which will represent the width, L, which will represent the length, and A, which will represent the area. To do this problem, it's going to be important to remember our formula for area, or how we calculate the area of a rectangle. It's calculated by multiplying length times width. So in words, we could write that out as area equals length times width. Or as a formula, we could write it as area equals length times width. So we're told here that the total area is 18 square inches, and now they ask us to sketch three possible rectangles that would have an area of 18 square inches. So we know that whatever the length and the width are, when we multiply them together, it needs to come out to be 18. So we could begin by thinking of pairs of numbers that multiply to 18. So I can think, well, 18 can be the product of the numbers 1 and 18. If I multiply 1 by 18, I get 18. Another way to get 18 is to multiply 2 and 9. And another way to get 18 is to multiply 3 and 6. So I could pick any of these pairs of numbers to represent length and width. I could have the length be 3 and the width be 6. Or I could have the width be 3 and the length be 6. And that would be another different rectangle with area 18. So this information here, these sets of numbers here, give me more than 3 rectangles, as we'll see, but we only need 3 here. So let's begin by using this pair of numbers, 1 and 18. So the first rectangle I might imagine could have a width of just 1. We could say, we could say L equals 1. Excuse me. So here could be a first rectangle with the length equal to 1 and the width equal to 18. We could take that same set of dimensions and switch it. So now let's say the length is going to be 18, so it would be a very tall rectangle. And we could say the width will be 1. So there's two different rectangles with area 18 square inches. In this case, L is 1. In this case, L is 18. For a third one, well, we have lots of options to choose for. Let's use that 3, 6 example. So let's say our length will be 3 and our width will be 6. So we could say L equals 3 and width equals 6. So there would be 3 examples of rectangles with area 18. When you're labeling things, it can be nice to include the area in it too. So you could say area equals 16, drawn right in the middle there. Here it might be harder to fit it in the middle, but you could try. And here as well. Kind of a follow-up question to these examples. We're asked, if L is 9, what is W? If we look over at our pair of numbers, if we have a 9 as either the length or the width and the area needs to be 18, the other dimension will have to be 2. So it tells us W must be 2. The width must be 2 if we're going to have a total area of 18. And now we're going to look at 2 key vocab words from this section, the idea of variables and constants. So we've been dealing with the symbols W, L, and A in this situation. The ones that are variables are the ones that could take on multiple values and still meet all the given conditions here. And the given condition here is that the rectangle has an area of 18 square inches. So we saw that there were many values of L that would work. We could have an area of 16, I'm sorry, I wrote 16, it should be 18 square inches for my areas there, excuse me. So returning to that question, we saw that L could be 1 or 18 or 3 or even 9, and the area would still be 18, so L is definitely a variable. And for W, we saw W could be 18, or W could be 1, or W could be 6, or W could be 2, and that given information that the area must be 18 square inches would still be met, so we can call W a variable. A, on the other hand, if we look at all the examples we did, A is always 18. And the given information comes right out and says A has to be 18. If we drew a rectangle that had an A anything other than 18, well, it wouldn't fit this scenario. So A cannot vary. The value of A is fixed, so that lets us know that A